Hello and welcome back to Precalculus, section 6.7 on the dot product. Now there are many dot products, but we are going to cover this particular one that we need for our two-dimensional vectors. Vectors could be three-dimensional, four-dimensional, 10-dimensional, and then linear algebra, n-dimensional vectors, meaning any number of dimensions. Now we only work with the two-dimensional vectors in this case, in this class, because it is everything is x, y, right? So we only have two dimensions to worry about. And the dot product of vectors u and v, actually, you know what, of vector u given by u1, u2 coordinates, could have gone with x and y, but whatever, and vector v with coordinates v1, v2, the dot product of u dot v is u1 times v1 plus u2 times v2, and that's equal a number, which is a scalar. So the product of two vectors will give you a scalar. Now, I know that, 3 times 5, that these don't look like vectors to you, and they're not equals to 15, but technically this is a two-dimensional version of the multiplication you already know. So this would be the one-dimensional, if there was a one-dimensional vector, right? That will be it. One-dimensional vector has only magnitude, it has no direction. I mean, there is a direction actually in these ones with a plus and minus. So negative 3 times 5 is negative 15. So you can think of it as a vector, and 3 times 5 is positive 15. So there is some direction to it because you go to the left or to the right, but you don't have as much freedom, right, as you have in xy coordinate space, and even less freedom, right, than the three-dimensional space that you can go in any direction you want. So let's find a couple of these dot products and then take a look at the really cool formula that we have and that we use for angle between vectors. But let's first say let u be 1 and 7 and v be negative 3 and 6. Doesn't matter. So u dot v, those are vectors, going to be 1, 7 dotted with negative 3, 6. So we don't say multiplied, we say the dot, the dot product. So is it a multiplication? Yes, it is a form of multiplication. But then there are other forms of multiplications that you get to learn later. One is called the cross product, and that's going to be for three-dimensional, seven-dimensional, and whatever other we get. So cross product is something that we still you are going to learn when you go to physics and calculus 3, and obviously linear algebra as well. So let's take a look at the cross product, this example, sorry, the dot product example here. So we have 1 times negative 3 plus 7 times 6, and that's going to be negative 3 plus 42 equals to 39. So the dot product of these two vectors, right, is a scalar, and the value is 39. Now that you can find the dot product, we can take a look at the use for this. And this is going to be the two formulas one that it's alternative formula for the dot product. So again, dot product definition, but it's the other way looking at it. So U dot V can be also the computed as magnitude of U times the magnitude of V times the cosine of the angle between them. So this is angle between vectors. That's what it is. And this is the formula that you get to flip around to find angle between two of these. So what do? Well, we solve it for cosine theta first, which is the dot product, which, remember, it gives you a number, divided by the multiplication of two magnitudes. Well, those are also give you numbers, right? And now, to get theta alone, which is the angle between the two values, you just use the inverse cosine. So theta is the inverse cosine of this mess. And there will be the formula that we use to find angle between two vectors. So, here's the question for you. Find the angle between vector u given as 1, -6 and vector v given by 5 and 8, whatever. So try to plug everything in the formula and get these values. And I'm going to change the ice pack for the last 15 minutes of the class. All right, let's take a look at this problem together. So you see that you have to find 3 different components, and each one of those will give you a number in the end. So we are going to find the dot product, u dot v. And that is going to give us 1, -6 dotted with 5, 8. So that's 1 times 5 plus -6 times 8, which is 5 minus 48, which is -43. We need the magnitude of vector 1, negative 6. And the magnitude is simply the square root of 1 squared plus negative 6 squared, which gives us the square root of 1 plus 36, which is the square root of 37. And finally, the last piece of the puzzle is magnitude of 5/8, which is, magnitude of 5/8 is the square root of 5 squared plus 8 squared, which is square root of 25 plus 64, which is the square root of 89. And now we have theta is inverse cosine of the dot product is negative 43, and the other two numbers for denominator, square root of 37 and square root of 89. So you can now either go each component individual, or you can, whatever. I'm going to multiply and take the square root to get the value in the denominator. So that's going to be the square root of 37 times 89, and that's 57.4. And this is my first checkpoint, because I just need to make sure that the number in the denominator is bigger than the number in the numerator, because the range of cosine, right, has to be less than 1. So cosine inverse of negative 43 divided by 57.4 is 138 degrees, 138.5 degrees. There we go. Now 138, right, that's the obtuse angle, and you can see that that is correct if you sketch these vectors, right? You don't need to wait for someone to validate your answer, because you can just see that it works if you graph these vectors on your in the xy coordinate plane. You have 1 and negative 6, which is 1 in x and negative 6 in y. Oops. It's so hard to draw straight lines when the tablet is rocking on these ice packs. So 1 and negative 6. So this would be my first vector. It's all wobbly. And the other one is 5/8. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, great. It's going to hit the number up there. But you can see that this is 138.5 degrees, because this whole thing is 180 degrees, right? It's a straight line. So these two, so this formula measures the angle in between two vectors. And that would be it for angle between two vectors and the dot product. There are other uses for the dot product, projection, orthogonal projections, and other things, but they will be all the part of your linear algebra class eventually, and calculus 3, which will also give you a lot of good info and base for your physics courses and engineering courses. So Yeah, we're not going into those gory details in this course, but they're coming up, and you will see them when you get there. Any questions regarding this lecture? All right, then see you next week. Bye.